Hi, welcome back. In the last video, we have shown you the normalization. I mean the problem area when the database is not when the data table is not normalized. So it's a big table, and you had we have shown you that we had hard time to finding the records, the maintain the records, and do the queries. Now we will be working towards a solution. So the first thing is once we get the table like the one we see here to the right hand side, let me create the pointer. Okay, yeah, this table, you can see the first step to normalize is to derive the functional dependency among the attributes. So you can see the student ID, student name, they are actually connected. I mean, they look same, right? I mean, there is these two are functionally dependent, and even not that. I mean, you have measure one, measure two, measure three. These are also functionally dependent. So you can say that functional dependence can be expressed as these expression: student ID arrow, and then you put student name, measure one, measure two, measure three. Usually a number, you can see the student ID is a good candidate for primary key field because, I mean, if you use a text, there may be duplicate student names, but the numbers will not be duplicate. So that's why we need to talk about the keys in as a path towards the normalization. The primary key field contains unique data for each record in a table and may not be left null for any record. The non-key field of a table should be functionally dependent on the primary key field. The primary key field may consist of a composite key, a combination of two or more fields. Composite keys are inherently more difficult to query and process than the single field primary key fields. Occasionally, more than one field contains unique information per record and thus could have single field primary key. Called the candidate keys, and the privacy concerns are a factor for on which to use. So when you talk about the first normal form, you can see this immediately see this table. Uh, it is in first normal form when it does not contain repeating groups more than one value in an attribute. Each column contains atomic values and there are no duplicate records. A relation that contains a repeating group is called unnormalized relation. A repeating group is a field that contains multiple entries. Removing repeating groups is the starting point uh, to make an unnormalized table to a first normal table. Okay, so here this table is unnormalized because you can see for each professor you can have multiple students. Not only that, I mean there are each student has three measures. I mean this is called, I mean this is kind of repeating groups. I mean you can how there is no straightforward way to make the data very unique in this case. So that's why we need the concept of atomic values. An atomic value is a piece of data that cannot be meaningfully divided. We need to make sure that each attribute contains one and only one piece of data, makes the data much easier to sort, search, and filter. So we need to examine each column to make sure it contains only one consistent piece of data for each record. In the programming paradigm, an algorithm is defined a set of steps to solve a problem. If you cannot define a consistent pattern to use with a programming algorithm to solve the problem, you are faced with the uh, with the struggle of manually updating the data. You need to strive to manually update the smallest amount of data as possible. So we need to come up with the algorithm to separate atomic values from a single piece of data. Generally, it requires a pattern that determines the start and stopping point of each atomic value. The algorithm to define the first name can be described like determine the location of space character in the student field. All characters to the left of the space character constitutes the student first name. So basically, what you need to do here is you have a student name like John Doe. This is a student name. So this is a student name. Now, what you have to do, there is a space character here. So you have to encounter this space character, and then this one will be the first name, and this one should be the last name. So that will be the basically essence of this algorithm. The algorithm can be, I mean, so you can define the algorithm to define the first name here and the last name here. Okay. So that's how you can create the first name and last name. I mean, that is a sample algorithm. Now, so in the Access database, you can do it in this way. I mean, you can create this like you can specify the fields in that way. That will be helpful for you to create the first name and last name. So typically, this view that you see on this picture, it's called a query design view. This uses built-in access function instr to first determine the numeric location of the space character in the current student field and is identified as a new calculated field named space. The third column uses the built-in access function of left to extract a number of characters from left side of the student field. The second argument of the left function identifies the number of characters to extract from the student field and is set at space -1, which is specifically precisely identifies the length of the first name for each student in each record. So now let's move on to the creating fields. So creating fields is one of the most straightforward ways to create new field in an access table, and that is to use table design view. Most relational database systems provide graphical tool to modify tables in various ways, but you can also use SQL statements to complete data definition tasks such as adding fields to table as well. So in this case, I mean, in the current situation, what you are supposed to do, um, you will right click the table in the navigation pane, click design view on the shortcut menu. To insert a new field in certain location, click the row where you want to insert the new field and then click insert rows button. Now click the field name cell and then enter the new field name. Click the data type list arrow and choose the appropriate data type. So you can see here, I mean, in this figure 512 shows the table design view um, of the raw data table with two new short text fields named student first and student last, which were inserted immediately after the student field. Now comes the updating fields. With the new columns created in the raw data table, you can use the formulas you constructed in the student names query to create the new atomic values for the student first and student last fields. And for updating field values using the query design view, you have to start a new query in query design view. Just follow these steps sequentially. Okay, start a new query uh, in the query design view. Okay, this step first, and then you add the table that contains the fields that need to be updated to the upper pane of the query design view. At the fields that you want to update the query grid, click the update button, enter an expression that identifies how to update each field in the update to cell for the specified field, click the run button. So these are the steps, and at the end of that exercise, you will see that this figure shows query design view of the expressions needed to update the student first and student first field in the update to row of the query grid. The expressions shows are the single expressions. You can see here the expressions. Uh, these are the single expressions. In single expression versions of the work you completed in the student names query when implementing the algorithms that identified each atomic value. Now, if you run this query update to all rows, then it often update queries are run only once and therefore are not saved when they are closed. The results of running this update query on the raw data table is practically shown in the in the in the it will be shown in the table. Let me try to show you the table after you run the raw data. Allow me for a second. I'm going to show you. So it will look like this. Basically, if you run it on the raw data, it will look like this. So next step is to create the first normal table. To create a table in the query design view, perform the following steps. Start a new query in the query design view. Add the table that contains the fields to be used in the new table. Add the fields that you want to update to the query grid. Click the Make Table button. Enter the new table name in the Make Table dialog box and then click OK. Click the Run button to complete the update. So often you run make table queries only once when you use them to move through the normalization process. Therefore, do not need to save them when you close the query. So the result, ultimately, the first normal table is shown here. You can see here, you have the student ID. There are student fields has been broken into student first, student last fields, and you can see the the each record contain only one measure here. So that's basically each column shows a unique value at least. So this is in the first normal form. The important thing is, you have to find out a way to find the duplicate values. So you can see here, you create a new ID for those rows, and you can see if you combine all these rows, student ID, student first, student last, professor ID, prof first, prof last, department major. These records are not duplicate. No two records are duplicate here. Every record is unique, and that's why you are creating some unique ID here, and that way you are creating the first normal form of the table. Everything is unique and there is no multiple values for a column. So you reduce you just solve the multiple value problems that we had in the major column. Before we have shown it in this column, we had the multiple values, so we solved it. No more no multiple values. No multiple values anymore. And there is no duplicate record. No duplicate records. So these are the two attributes that we have accomplished when we create this first normal table.